students, welcome back. Today we will continue with exercise 1.2 of chapter number 1, relations and function. In our last video lecture, we had started with exercise 1.2. Okay, now we have completed question number 2. Today we will start with question number 3. Okay, so let's start. Question number 3. Prove that the greatest integer function f r to r. Okay, the function here is from r to r. Okay, what is fx? Fx is equal to greatest integer function x. You have to prove that this is neither 1 1 nor onto, where the square bracket determines the greatest integer less than or equal to x. So first, let's take a quick revision. What is greatest integer function? Okay, I will just give you example. If I am writing 3.5, so what does this mean? 3.5 lies between 3 and 4. So greatest integer, okay, which is not greater than 3.5. So that is equal to 3. Clear? So if it is 7.99, then it will be equal to 7. If it is 7, then this will be equal to 7 because 7 is not greater than 7. Clear? So this was about the greatest integer. If it was least integer, then here the answer will be 4. Here the answer will be 8. Here it will be 7. If you are taking integer, then whether it is greatest integer function or least integer, in both the case the answer will be that integer. Okay. So this is a quick revision. What is greatest integer function? Clear? So now you have to prove not 1 1, not onto. Okay. That's good that it's already, you already knew that it is not 1 1. You just have to prove it. Okay. So first for 1 1, when we have to prove not 1 1, then what we are doing? We are finding the example, right? Now it's from R to R. So I will take two values like 3.1, which is not equal to 3.2, right? But what is f of 3.1? This will be equal to greatest integer. So which is the greatest integer not greater than 3.1? 3. Okay, same way f of 3.2, that is equal to square bracket, that is greatest integer function 3.2. This is also equal to 3. See, 3.1 is not equal to 3.2, but f of 3.1 is equal to f of 3.2. Hence, it is not 1 1 function. 1 1 function. Clear? Okay. Now it's time for not onto. Clear? Remember, in greatest integer function, your answer will be always integer. Now, what is the codomain here? R. That means it includes also the number with decimal, right? You can say that 3.5 belongs to codomain, right? What is the codomain here? R. And what is the range? The range will be integer, right? Here, range of function is equal to z. Clear? Therefore, 3.5 does not belongs to range of function. So what does this imply? Range of function is not equal to codomain. Instead, it is a subset. Therefore, it is not onto function. Okay, onto function, not onto function, you can also call it as into. Like not 1 1 function, you can call it as many one. Okay, so this is question number 3. See, it is neither 1 1 function nor onto function. Clear? So just note down question number 3. Now let's move to the question. Okay, question number 4. So that the modulus function f r to r, okay, let me write it down. The function is from r to r, given by f of x is equal to modulus of x is neither 1 1 nor on 2. Yes, that means you got the hint. You already know it is not 1 1 and not on 2, so you just have to prove it. The modulus of x is if x is positive or 0, and modulus of x is minus x if x is negative. Okay, we already know this. Yeah. Okay, now see, for 1 1, let's take example. What is our, let's take minus 3 and 3. Both this belongs to R, right? What is f of minus 3? This is equal to modulus of minus 3, and that is equal to, what is f of 3? This is equal to modulus of 3, and that is equal to 3. Now see here, minus 3 is not equal to plus 3, but f of minus 3 equal to f of plus 3, therefore it is not 1 1 function, or it is many one function. Clear? Okay, now let's see for onto. Okay, so you already have to prove it is not on. Right? Now see, when you take modulus, your answer will be always positive. Right? If you take 0, your answer will be 0. Apart from 0, you take any value, either it is negative or positive, its modulus value will be always positive. But here the codomain is R. Means minus 1 belongs to codomain. Okay, minus 1 belongs to codomain. Here codomain is R. But minus 1 does not belongs to the range of function. Right? Because range of function is the positive numbers plus 0. Okay? Therefore, range of function is not equal to codomain. Hence, it is not an onto function. Here, this was about question number 4. So just note it down. Okay, now if you want to make this function 1 1, then how will you make? When can you say that this function will be equal to 1 1? See, if the function is such here, if we change this, right, if it is from n to n, right, that means we can only take positive number. So for any number you will not get fx, for any two different number you will not get fx1 equal to fx2. Clear? Okay, then it will be 1 1, and also here it will be n, so positive numbers will be only there. Okay, then it will be also on. Okay, now let's move to the next question, that is question number 5. Question number 5. So that the signum function f r to r is given by fx equal to, okay, let me write down this. Here the function f is from r to r. What is fx? This is signum function. So this will have only three values. 1 if x is greater than 0, 0 if x is equal to 0, and minus 1 if x is less than 0. So it has three values, 1, 0 and minus 1, right? So first it's very easy now, and also it is given that you have to prove it is neither one word nor, right? Now let's take any two positive number, any two number greater than 0, 3 and 5. Both of them belongs to the R, means domain, right? What is f of 3? In this case, greater than 0, so 1. What is f of 5? Greater than 0, so it's 1. See, 3 is not equal to 5, but f of 3 equal to f of 5. Therefore, it is not one function. Here, this was about one function. Okay. Now, let's see about onto. Now, see what is the codomain? Codomain is R. Means it includes all the integers, positive integers, negative integers, okay, zero, right? Also decimal value, every number. But here we are having only three things. The range is here, range of function is 1, 0, minus 1. What is codomain? Codomain is equal to R, right? Means you can say that 2 belongs to codomain. I select any ones, but 2 does not belongs to range of function. That means range of function is not equal to codomain, okay, or range of function is subset of codomain, therefore it is not onto function. Clear? Okay, so this was about question number 5, so note it down. Sorry, it's not equal. Okay, instead I can say range of function is subset of codomain. Now let's move to the next question, that is question number 6. Question number 6. Let A equal to 1, 2, 3. Let me write down. Here it is given. A is equal to 1, 2, 3. B equal to 4, 5, 6, 7. 4, 5, 6, 7. Okay. The function f is from A to B. 1, 4, 2, 5 and 3, 6 be a function from A to B. Now show that f is 1, 1. Okay. Now see, whenever we are writing any ordered pair like this way in a function, like 3, 5. So what does this mean? If this is x, then this is f of x. Means f of 3 equal to 5. Clear? When ordered pair is written in this way, it means this. Here when you are drawing the graph, this you are taking x coordinate, and this you are taking y coordinate, that is fx. Clear? So now you have to prove that it is a 1, 1 function. Now see, from here, what is f of 1? 4. What is f of 2? 5. What is f of 3? 6. Right? So see, each element is having only one value and that is not repeated. Here we will take 1, here we will have only one value. Right? If I draw using an arrow diagram, okay, like 1, 2, 3, and in this case it's 4, 5, 6, 7. The relation is such way: 1 related to 4, 2 related to 5, and 3 related to 6. See, 1, 1. You can clearly see this is 1, 1 function, right? Hence, it is 1, 1 function. Clear? Okay, so this was about question number 6. Okay, now one extra part. What will be your answer if there is one more question, that is it an onto function? Right? If the question is asked, if these are all the ordered pairs of function f, then is it an onto function or not? Then what will you say? No, it is not an onto function, because in the codomain, right? In the codomain B, there is an element 7 which do not have any pre-image in the domain, right? What is an onto function? The onto function is such that for every element y belonging to B, there is an element x in A such that fx is equal to y. Means for every element of B, there must be a pre-image in the domain, right? So here there is no pre-image of 7 in domain, hence it is not an onto function. Clear? But see, the question here is only one, so we will only note down till here. Okay, so note down question number 6. Okay, so that was about question number 6. Now let's move to the next, that is question number 7. Question number 7. Okay, in each of the following cases, state whether the function is 1, 1, onto, or bijective. Justify your answer. Now see, here there are two questions, but now see, here it is state whether, means now you don't know. In the previous question it was like prove it is not 1, 1, prove it is 1, 1. So already knew it, right? What you have to prove. But now here it can be 1, 1, it cannot be 1, 1. Now one more term here, it's bijective. Right, now what is bijective? Bijective means a function when it is both 1, 1 and onto, then the function is called bijective, right? See, one function, that is also called as an injective function, and onto function surjective. And if it is both injective as well as surjective, means both one and onto, then it is called as a bijective function. Okay, so now first let's start with the first one. F R to R. Okay, and it is defined as fx is equal to 3 minus 4x. Okay, so there are two options. If you want to prove not 1, 1, then just take an example. So if you try to find out any example, you will not get it. If I take 1, it will be 3 minus 4 minus 1. If I take 2, 3 minus 8 minus 5. If I take 0, 3 minus 0, 3. Every time we will get different option, right? So it is 1, 1. So what was our step to prove 1, 1? Okay, take x1, fx1 equal to fx2. Okay, so what I am doing, I am taking fx1 equal to fx2. Okay, let fx1 equal to fx2. So what does that implies? 3 minus 4x1 equals to 3 minus 4x2. Okay, 3 3 gets cancelled. That implies minus 4x1 equal to minus 4x2. Minus minus gets cancelled and 4 4 gets cancelled. So this shows that x1 equal to x2. So we started with fx1 equal to fx2 and we ended at x1 equal to x2. So what does that mean? That means that it is one function. Okay, now for onto function. Okay, now see what you have to do for onto function. Whenever there is a square, so here it's not square, it's 3 minus 4x. Clear? Now, obviously, when it is r to r, so whatever different values of x you take, for every answer, you will have one x in fx such that fx is equal to y. Okay, so we'll prove it theoretically. Like we will take fx is equal to y. Here we will take fx is equal to y. So what does that implies? 3 minus 4x equal to y. Okay, so minus 4x equal to y plus 3. So 4x is equal to minus y plus 3 and x is equal to minus y plus 3 by 4. Common, I have taken a bracket here, so it will be minus y plus. Yes, sorry, my mistake. Here it will be minus. Okay, so let me change it. Here it will be y minus. Okay, so 4x will be equal to 3 minus y. Okay, x will be equal to 3 minus y by 4. Okay, I got this x. So f of x will be equal to f of 3 minus y by 4. Clear? So what is fx? Fx is 3 minus 4x. 3 minus 4. If it is x, here it will be x. Here it is 3 minus y by 4. So 3 minus y upon 4. So 4 gets cancelled. 3 minus 3, 0 minus minus plus y. Right? So what does that mean? For every word belonging to codomain, that is R, there exists x belonging to domain such that f of x equal to y. Therefore, it is onto function. Okay, and as it is onto, hence it is. Let me write down it here. Okay, I will write it down. Hence, it is bijective function. Why? Because it is 1 1 as well as onto function. Okay, so it is bijective. Clear? So this was the first part of question number 7. So just note it down. Okay, now let's see the second sub question of question number 7. Second one, uh, f r to r, right? Again, the function is from r to r, defined by fx is equal to 1 plus x square. Okay. Now see, whenever there is a square, okay, you know that when you will take positive value and negative value of the same number, its square will be same, like square of minus 2 is 4 and square of plus 2 is 4. So when you have to prove whether it is 1 1 or not 1 1, you have to check it. Try to take one positive and that negative number. Okay, so let's start with minus 2. Okay, what is f of minus 1 plus minus 2 square, that is equal to 1 plus 4, and that is equal to 5. Now f of 2, that will be equal to 1 plus 2 square. Again 1 plus 4 equal to 5. So I got the example, right? Minus 2 is not equal to plus 2. But f of minus 2 is equal to f of 2, therefore it is not 1 1 function. Okay, so clearly it is not 1 1, that means it will be never bijective function. Okay, but we need to check it for the onto function. Okay, now for onto function. Now for onto function, what do you do? Here it is a square. Here, so if I just take it as 0, what is the minimum value? Let's take here. What is the minimum value of x square? 0, right? It can have 1 2 3 4 5 any value, but it cannot have value less than 0 because square is never negative. Okay, so 0 plus 1, that is 1. So this function will have minimum value 1, it cannot have value less than 1, right? So what does this knows? That fx equal to 1 plus x square, this will be always greater than equal to 1. Okay, but see, what is our codomain? Our codomain is R, means R includes 0, means 0 belongs to codomain. What is the codomain here? R. But 0 does not belongs to range. 0 does not belongs to range, right? So here range is not equal to codomain. Range of function is not equal to codomain. But let me write down this time. Range of function is subset of codomain. Okay, means all the elements of codomain are there in range, but all the elements of all the elements of range are there in codomain, but all the elements of codomain are not in the range because 0 belongs to codomain. So there is not any element in the domain such that fx will be equal to 0. Okay, hence it is not an onto function. Okay, so see here, it is neither one function not an onto function. Therefore, it is not a bijective function. Okay, so this was about question number 7 and its sub question second. So remember this, whenever there is a square given in the function for 1 1, try to take one negative value and one positive value of the same number. Okay, and then for the range, if it is belonging to R, right? See, if the codomain is R, and if any equation like this is given, okay, if any equation like this is given which you can convert into perfect square, right, then it will be never equal onto function, provided the codomain must be R. Okay, so note down question number 7. If you are still not able to convert in perfect square, if the function is like this, let me give you one example. If the function is fx is like this, 5x plus 3 plus x square, right? What you can do, you can find out the last term. You can arrange in this way: x square plus 5x plus 3, right? You know the formula for middle term, right? 2 into square root of first term into last term, right? So middle term square, what will be the formula for last term? Middle term square, I'm writing in short, upon 4 into last term. Okay, sorry, first term. That will be the formula for last term. So in this case, what is middle term square? 5, so 25 upon 4 into first term. What is first term? 1. So this will be 25 by 4. So I can split it in this way: x square plus 5x plus 25 by 4 plus 3 minus 25 by 4. Okay, so this will be equal to x plus 5 by 2 whole square. 4 3s are 12, 12 minus 25 minus 13 by 4. So see, once I get this, the minimum value of this can be 0. So 0 minus 13 by 4. So any number less than minus 13 by 4 will be not possible. So the number which will be less than minus 13 by 4 will be there in R, but will not be there in the range of function. Okay. So by that way you have to prove it is not on. Okay. So at present this is not important. Just note down question number 7, part 2. Okay students, so that's it for today. In our next video lecture, we'll continue with question number 8 and we will complete this exercise. Thank you.